still 13.3. We're looking at finding the sum of a finite arithmetic series. So again, a series just means that we're adding together a sequence. So there is a formula for it, which you can see on your screen there, which is also in the notes. But it's saying that S sub n, so saying the sum of our n terms, is going to equal n. So the last term, I'm sorry, or the number of terms, excuse me, not the last term, the number of terms, times your first term plus your last term, and then all of that divided by 2. So if we take and look at the example that we did on the previous video, so the Gauss example, looking at 1 plus 2 plus 3 all the way up to 100, adding that series together. If we apply this, well, we know from 1 to 100 that there's 100 terms, so we'd be looking at S, the sum of 100 terms. So our n value would be 100. Our first term, t sub 1, will be 1. Our last term, so t sub 100, would be 100. So we'd be looking at taking 1 plus 100 and then dividing that all by 2. Now, you may say that this doesn't quite look like what we did on the previous example, but it's pretty close. If we look at 100 divided by 2, you're going to get the 50. And then 1 plus 100 is going to give you that 101. So we are still getting that the sum of the first 100 terms in this series is going to be 5,050. But that's a quick example of how to use this sum of a finite arithmetic series. My next example we'll talk about, or my next video, we'll talk about the geometric. So I'll see you soon, or you'll hear me soon, I guess is maybe a better way to say it. Thanks for listening.